Hey, so in this video I'm going to talk about the EEPROM, which is what's storing the program our computer is going to run. This is the first time I've really talked on a video before that I've recorded myself. It's a bit weird, so I might stutter a lot. You're just gonna have to ignore that. Things that I say might not make sense. Anyway, I would say, I don't know, maybe 2 weeks ago, I wired up the EEPROM, which is basically what you could compare to a hard drive of a normal computer. Wired it all up, 32 kilobytes. The bytes are 8-bit, obviously. And I wrote, I would say maybe, I don't know, I'm just gonna say 300 lines of code, which sounds like a lot, but it wasn't that much. Still was a lot of effort. 300 as in lines that aren't comments and stuff. I have it split into multiple files. Anyway, so I wired it all up, wrote the program, was super excited to try it, and it didn't work. So I checked the wiring, still didn't work. I checked the program, I hooked up my oscilloscope. All the pins seemed to be going on and off on the Raspberry Pi, which is uploading our program to the computer we're making. All the pins were correct, so I couldn't figure it out. All of a sudden I realized the EEPROM was flipped. So first of all, the polarity was completely reversed. Second of all, every single other pin was incorrect. So that fried it. It was a more sensitive part. But it probably would have fried pretty much any other TTL part or any part in general. Anyway, point is, I got super discouraged and I stopped for like a week and a half maybe. Just got back to it, and this time, first of all, I bought more EEPROM. I bought 2 just in case, and then a whole bunch of other stuff that I'll probably never need to use. Second of all, I'm making every single part of this individually and testing it individually beforehand. And I just got the counting working. And you'll notice that the Raspberry Pi is, I'm not expecting you to be able to see this. I'm kind of holding a DLSR and it's kind of awkward right now. But it's hooked up to a counter, which increases by 1 instead of going directly into the address lines of the EEPROM. And the reason for that is basically I didn't have a whole lot of diodes at the time, but I couldn't just hook up basically the counter would either put out 5 volts destroying my Pi, or 0 volts, sinking the whole thing to ground and making the input 0 every time. And I didn't want to figure out how to do it without buying more parts, so I thought, hey, why not just hook up the Pi directly to the counter, which I did. And it's a lot slower, but it is working really well, actually. I just got it working today. And the counter only counts to 255, and then the other 7 bits, I think it was, are going to be controlled by another register that the Pi will also be hooked up to instead of directly to the address lines because of the same reasons. And it takes about a minute to upload. This isn't actually uploading anything yet, it's just counting, which I know sounds super lame, but I'm just glad that I got it working. Here it is in action. Let's see. Once again, it's pretty awkward holding the camera. So you can see it's kind of slow. I think I calculated it to be like 500 bytes per second, or it was 533 and a third. And you can see the LEDs are blinking super fast, counting to 255 over and over. They reset every single page, and then when the page turns, they start from 0 and go to 255 again. And I have all the, I have lines like this, where it's, it sleeps for 500 nanoseconds to let the EEPROM take it in. I think that's the wrong line. It was actually 350. but you know, I looked at the data sheet to see. I always went either 5 or 10 nanoseconds over, but I made it as short as I can besides those 5 or 10 nanoseconds. And just finished, actually. 100% complete. The things are all lit up. Anyway, that was 32 kilobytes. And that's just the counting part in action. I'll post the next parts.